Today we're going to move to investigation 2 of What Do You Expect? So we're starting out on page 20. We're still doing probability, but what we're doing now is looking at other ways to find probability. Yesterday we worked on the tree model, and today what we're going to do is use an area model. So if you look in the online textbook at page 20, you can see that they've presented another game. Bucket 1 contains 3 marbles, and bucket 2 contains 4 marbles. So my book isn't colored, but online you should see the colors of the marbles. So what we're going to do is illustrate this and then show the area model. So I'm just going to sketch this out real quick. Alright, so we've got 2 buckets. Alright, bucket 1 has 3 marbles, bucket 2 has 4. Alright, so it says bucket 1 has 1 red and 2 greens. One of y'all pass me a green crayon? And then bucket 2, pass. Not throw when you're not looking.
I didn't throw it, I tossed it.
Alright, a red, a blue, a green, and a yellow. Okay, so we've got our little game set up. Now we're going to do a square grid. Okay, this side will be bucket 1. This side will be bucket 2. Alright, so the square represents probability of 1. So I should probably say each. Oh, of 1. So that's 100%. So if the entire square is filled in, that would be 100% chance of your event happening. Okay, so bucket 1 has 3 choices, and so we'll divide bucket 1 into 3 equal sections. Because if I reach into bucket 1, I have an equal chance of pulling one of the 3 out. Okay, so then let's label the colors. So we have a red marble, and we have 2 green marbles in bucket 1. Yeah, it told us in the directions that we had 1 red and 2 green in bucket 1.
I thought it was red, yellow.
Okay, now for the second action, when we choose a marble from bucket 2, We'll also have to divide bucket 2 into equal sections. Now, how many marbles are in bucket 2?
4.
So how many columns will I have for bucket 2? Okay, so I'll need 4 columns. Alright, so I'm going to label bucket 2's colors below. So we have a red, a blue, a green, and a yellow. Alright, so now each sub-region, which is inside here, will represent a possible outcome. Alright, so watch what I'll do here. So, which one do they go first? Alright, bucket 1 first. So this subdivision would be a green, I'm sorry, you can't see that. A green and a yellow, which is GY. Green and yellow. This one would be choosing the green and the green. This one would be choosing a green, then blue. Let me zoom that in for you. This one would be a green, then a red. Okay, and the next row, we would have a green, then yellow. Green and green. Green and blue. Green and red. Okay, and then I could choose a red, then yellow, a red, then green, a red, then a blue, or a red and then another red. Okay, so a summary of what we just did is I took my square, I divided it into sections based on how many marbles were in bucket 1, how many marbles were in bucket 2, so that I could see my outcomes. So everything on the inside will be my possible outcomes. The possible things that could happen from drawing one from each bucket. So, how many total possible outcomes do we have? 12 total possible outcomes. So if I'm finding the probability, it'll be out of how many? 12. Okay, so what's the probability in this situation of pulling a green, then a green? So a probability of my event being green and green. Jay? Okay, so yeah, you look up here, green and green happens 2 times out of a total of 12 possible times. But when we write our probability, if it's a fraction, simplify, divide by 2 would give me a 1 out of 6 chance of pulling a green and then another green. Now, what if I want to make this into a decimal? What do, Erica? I'd say 1, in my calculator, I'll type 1 divided by 6. So I would get 0.1, and that 6 repeats, so I'll round that to that next one to a 7. Okay, well, what if I want to make that decimal a percentage? What if it says, what's your percentage? Kendall? I bump 2 times towards the percent sign. Bump. Would give me a 16.7% chance of success. Okay, what is the probability in this game? What's the probability of having green then blue? Cesaria? All right, again, I see 2 in my outcome of green then blue. 2 out of 12, which reduces down to 1 out of 6. What's the probability of having a blue and then a blue? Sarah? 0 chance. 0 out of 12. So if that's a game at the carnival, and to win I need to pull a blue, then another blue, do I need to play that game? I'll never have a chance of winning. So that would not be a good choice.
There's not a blue and a blue anyways.
Exactly, that's what I'm saying. There's no chance of winning that, so don't play that game. Okay, what's the probability of choosing a red from either bucket? Let me write that down. Now I just need to pick a red. It doesn't matter if I get it on the first draw or the second draw. If I just have 1 red, what's my probability of at least getting my 1 red? Shelby. All right, let's look up here at our outcomes. So I'm going to count all of the ones that have a red on either draw. Okay, because I just need a red. I just need a red from either bucket. 1, 2, 3, 4, 5, 6 out of 12. All right, now, am I going to leave it 6 out of 12? What will I do? We're going to divide them both by what?
6.
I could divide them both by 2, but
6.
let's divide them both by 6. If we divide it by the greatest common factor, it's less work in the long run. So 1 out of 2. What percentage is 1 out of 2?
50.
What percentage would be 50%? Are those good odds?
Yeah.
If you're playing a game at a carnival and you have a 50% chance of winning, that's pretty good odds for a carnival game. So that would be a one that you would want to pick maybe. How many of you like this this way to find your results? Better than the tree?
Yes.
Okay. Okay, whichever one you like, it's fine to use the tree or this. They'll give you the same results. All we're doing is trying to show you all the possible outcomes so that you won't miss any. All right, if you'll look over at page 22, we can see another type of game. It's called Making Purple.
What? Making purple?
Yeah. Okay. So, here's their carnival game. It says the popular game at the school carnival is a spinner game called Making Purple. To play the game, a player spins the pointer of each spinner once. Suppose the player gets red on the one spinner and blue on the other spinner. Well, that's a win because red and blue mixed together make
Purple.
So, the way to win this game is to make purple. So, will it matter if I spin red or blue first or second?
No.
I just need to make sure that I get one red and one blue, and then I'll make purple. Okay, so let's see what we need to practice here. Alright, so part A says play the Making Purple game several times and record your results on each turn. Based on the results, what's the experimental probability that a player will make purple on a turn? So, here's what we're going to do. Remember the Google Doc that we opened the other day on our spinner game? Okay, well, if you'll go back to Canvas and open it again, it'll give you a fresh sheet for this new game. So, then you'll have to open the spinner again and then practice spinning and trying to make purple so that you can record your experimental probability. Okay, and then after you see what your experimental probability is, you're going to write down what your theoretical probability is. And theoretical probability is taking those numbers, maybe making an area model or maybe using your tree, and finding out what the exact probability would be to make purple, theoretically. And then you're going to compare your experiment to the theory. And then we're going to answer D together. So if we could do A, B, and C, where you play the game for a minute, record your experiment, then come up with your theory. Okay? All right, y'all go ahead. All right, so now on page 23, it's problem 2.1. Okay, so we're looking at the Making Purple game, and we are finding the theoretical probability for this game. So spinner A has 6 sections. And spinner B has 3 sections. And let's pretend that the ones I drew are like the ones in the book and they're all equal size. Because obviously if they're not equal size, then the probability changes for the specific colors based on the size. But these are all equal sizes, equal chance.
I didn't get it.
Uh-oh, I did an extra one.
Can we put the first one?
Okay, so we get 1 spin on each spinner, and to win the game we have to make purple. So we're going to find the probability of winning in a minute, bless you. But first let's look at our possible outcomes. If you like to do the tree, go ahead and do that. If not, if you like the diagram, then you can use that, the one we just learned. So if you draw your, let me see how many we're going to need. 1, 2, 3, 4, 5, 6. Draw your square. Okay, this will be for spinner A, and this will be for spinner B. Alright, spinner A has 6 sections. It's got a red, a green, another red, a yellow, another red, and a blue. Spinner B has 3 sections. Has a green, and it has a red, and it has a blue. Okay, so once you have it labeled, then you can fill the inside in with the possible results. So a red then green, a red then red, a red then blue. Bless you. Green then red, blue, red then green. Bless you. Oops. Okay, so when we use our diagram, we can find the probability of getting purple. Peyton, can you pass me that purple marker? Alright, so what does it take to make purple?
Red and blue.
And it does not matter what order. Alright, so what's my probability? How many times could it possibly happen? 4. Out of how many total outcomes?
18.
Alright, and we won't leave it like that. They're both even, so we know we can divide them by 2. So I have a 2 out of 9 chance of making purple. Okay, so then on part D, the first question says, how much money will the school take in from the game? It says the cost to play the game is $2 and 36 people play the game. So if the cost is $2 and 36 play, how much will they make or take in? James, if you take 2 and multiply it by 36, the school will take in $72. Okay, so then it tells us that the winner will get $6 if they make purple. Okay, so if the winner gets $6 and we use our theoretical probability, how much would you expect the school to have to pay out in their prizes? You remember what we did yesterday? It's just a ratio. It's just a comparison. Erica? What did you put to work that out? I'm not saying you're wrong. I'm just saying, tell me what you did. Why don't we let the small groups work for a second? Small groups work for a second. See if you can come up with how much would the school expect to pay out in prices. Okay, so when we set up our probability, first we have to see approximately how many winners there would be. Okay, so if we set up our ratio of 2 to 9, and we know that 36 played, this unknown here would tell us approximately how many should win based on our probability. All right, so I like to use multiply up, divide down. So 36 times 2 is 72. And so then 72 divided by 9 would give me 8. So we would expect that there would be about 8 winners. All right, and if the winners get $6 each, and we take 8 winners times the $6, the school would expect to pay out about $48. So then the final question is, well, how much profit will they make then? If the theoretical probability occurs, approximately how much profit should they make? How do I find that? If I know they take in 72, they'll have to pay out 48. Lily? Okay, so then when we take our 72 and take away our 48, the school should make about $24.